Alright, let's just show you a little project I've been working on. At work, we were installing CTs in these electrical panels just like this one. And I bought 4 of them. 2 of them came damaged, as you can see right there. There, the CTs were damaged. I had to take the CTs off of this one. Hopefully I'll be able to replace them. Find a replacement for them. Anyways, so what I got here is a little setup. This pink cord right here plugs into this box right here. And this switch right here controls this little power port, or the receptacle that this is plugged into. That's just the meter. So when I turn that switch on, this meter turns on. But as you can see behind there, I got, it's kind of hard to see, but I got a wire sticking out of the box. And I got a blue CT, a Snyder CT, and the wire's going through one of these donuts, tied together with the wire nut on the other side. And then of course my meter's on there. I got a little really nice meter that can read AC voltage and DC voltage, DC amps and AC amps as well. But I was just messing around our Arduino. Let's see if I can use Arduino to get information out of these CTs. And so this big CT array is using a ribbon cable that goes to a little terminal block. And I just take I got the red and black wire that represents the CT that my load is currently going through. And then I got a 4-port analog to digital converter. The CT array is plugged in to this first one. The second one, this white wire, goes to this, which is connected to the blue CT. And then this black and white cable right here is going to the third port. It's connected to the Snyder CT. But you see, you got A0, A1, A2. A0 goes to the CT array. A1 goes to the blue CT. A2 goes to the Snyder CT. Alright, and then this orange and yellow cable is basically a 2-wire communication that the Arduino uses to talk to the analog to digital converter. So the yellow and orange is going to my Arduino board and connects to the system clock and system data of the ADC. So, and then I got it plugged, the Arduino plugged into a Raspberry Pi computer, which has got a wireless keyboard. I'm using a wireless keyboard and mouse with a monitor right there, and that's my Arduino program running right now. And that's the information I'm getting out of it right now. So right now I don't have it turned on. So the first thing I'm going to do is switch this on, and all it does is power up the meter. And as you can see from there, I'm getting, when I turn it off, I get 0. So the little meter pulls about 0.04 amps or 40 milliamps. Up here, it kind of reflects it. You can see the load amps, 0.3, 0.4, around that range for each different CT. And then this black cord right here is going to a little space heater that has 2 heating elements in it, and each heating element pulls about 2 amps. So if I turn the dial to 1, one of the heating elements will come on, usually the bottom one, and then let's see. The meter shows it to be pulling. Oh, the meter must not be closed all the way. Come on now, there we go. Meter shows about 2.14 or 2.15 amps. And that's what I'm reading on each one of my CTs. I got the CT array, I got the blue CT and the Snyder CT, and the load amps are all about the same, with one heating element turned on. So I'm gonna go ahead and crank it up to 2. We'll to turn on the second heating element, and instantly I got 4.3 amps on my meter, and then my Arduino is reading about the same. So on all 3 CTs, different CTs by different manufacturers, they're all reading about 4.2, 4.27 there. And then I guess I could just show you my code. And there's my code right there that prints the values in the serial monitor. And each different CT gives a different voltage rating based on the load that's going through the CT. And I just had to use my meter to determine how many amps is going through the circuit, and then I take that and divide it into whatever voltage I'm getting, and that gives me the conversion rate. And once I got the conversion rate, you can see the conversion rate right there for getting the amps is different for the CT array, and it's from the conversion rate of the blue CT and the Snyder CT. They all got different conversion rates because they have different voltages for whatever load you got going through the CT. So I'm going to go back to my serial monitor. Alright, now I'm just going to go ahead and flip this switch off. And you can see, I just flipped it, so now I'm getting 0 amps. Zero amps on my meter. I flip the switch, turns the heater on, goes straight up to 4 amps. You get 4 amps on that. So ideally I want to be able to monitor, use one of these CT arrays in my home, and then connect it to Arduino, and then I can use Arduino to connect to my Wi-Fi, and then I can monitor all my branch circuit loads in my house through my computer or remotely or whatever. But now I got the basic hardware working. I guess the next step is the Wi-Fi. So and here's my computer. This is my main computer. And I got 2 screens, one for reading PDF files, one for basics, you know, a normal computer screen. And then I got another Raspberry Pi computer down here, and I could use That's just my little basic setup. There's my oh yeah, I've been practicing my Wi-Fi, my RFID reader. Been trying to get some Skylanders working, but it's tougher than it looks. And then a bunch of cool stuff you can do with Arduino. So maybe I can get this working in my power panel. It's kind of fun. So yeah, I'm using my Arduino or my Raspberry Pi to program my Arduino, which is kind of cool in itself. It's amazing how that Raspberry Pi is such a small computer in itself, and you can do so much with it, including programming that. Of course, this, you know, I like to program in my main computer too. It's a lot faster. But that's it. That's all for this video.